All right, today we are going to solve a classic math puzzle all about function transformations. We're going to break down this handwritten solution to see exactly how you find the right answer, especially when your first guess isn't quite right.
So let me ask you this. What happens when you follow all the steps? You do everything you're supposed to, but your answer is wrong. It's really tempting to just erase everything and start over. But what if that wrong answer is actually a clue? We're about to see how an error isn't a dead end at all, but more like a signpost, pointing you right to the correct solution.
First up, let's get our heads around this transformation puzzle. We really need to become detectives here and figure out exactly how this function has been shifted and stretched. Okay, so here's our core equation. Y equals k times f of x plus a. Our entire job is to find the secret values for k and a. Now, k is the multiplier. It's the one that handles any vertical stretching, shrinking, or even flipping the graph upside down. And a, that's the vertical shift. It just moves the whole graph up or down. Our mission then is to find the specific numbers for both. And these are our clues. We know we have two original points. One is at 2, -1, and the other one is right at the origin, 0, 0. And we know that after the transformation, they've moved to 2, 5 and 0, 3. The real question is, how do we get from those starting points to the target points using our equation?
Now, for our first attempt, a great way to solve problems is just to start simple. So let's try the most straightforward, obvious transformations first and see what happens. Okay, the logic here is pretty solid. Let's just try a simple reflection. That means we set k equal to -1. This just flips our starting y values, so -1 becomes +1, and, well, 0 stays 0. Then, if you look at the point 0, 0, we can see it needs to end up at 0, 3. The easiest way to make that happen is just to add 3, right? So we'll set a to +3. So when we apply this new rule, y equals -f of x plus 3, we get 0, 3, which is perfect. But we also get 2, 4. And that's a problem.
And this shows our problem perfectly. We've got a wrong answer. You can see in the source notes, there's a big red X because 2, 4 is not our target of 2, 5. But here's the thing. We are not starting over. This is actually a super valuable clue. One point is right, the other is wrong. That means our transformation is partially correct, but something important is missing.
All right, time to put our detective hats back on and really analyze this error. Why on earth did it work for one point but not for the other? The answer is hiding in how k and a work together. Let's really focus on this. The point at the origin worked out great. Why? Because multiplying its y value of 0 by anything still just gives you 0. The error only showed up when we used the point 2, -1.